Right, so the bonus says find k. So k is our goal. Find k so that y equals 4x minus 9 is tangent to this function, which is a parabola. And so we have a parabola and then a line that's going to be tangent to it. All right, so you want to start with what you know about tangent lines and the slope of a tangent line. This is our tangent line. So hey guys, what is the slope of this line? Just by typing it in the chat, what is the slope of this line? Four. Good, awesome. Our slope of the tangent line is 4. And so we're going to set our derivative equal to 4. Derivative gives you slope of the tangent line. So we're going to do the derivative of this and set it equal to 4. So this would be 2x, and then k is just a number, so that's a constant. This is going to be like minus some number, so that derivative is 0. And so this is our derivative. This is our slope of the tangent line. We're just going to set those equal. So I've got 2x equals 4, and so x is 2. And I know you're probably like, Ms. Cole, but we don't want x, we want k, so how did that help us? Well, we have to get x and y before we can plug in and solve for k. We need both of those. So if x is 2, I'm just going to plug 2 back in and see what I get for y. So if x is 2, this would be 8 minus 9, so that would be negative 1. And so in this function, I'm going to put in negative 1 for y, which would be the f of x. This is, the output. So that'll be negative 1, and then I'm going to put in 2 for x. So we'll have negative 1 equals 2 squared is 4 minus k. And so we're going to subtract the 4 over. And so negatives cancel and k is 5. And let me just show you what this looks like on the calculator too, because I had a lot of people trying to draw it, which was really cool. But I just want to show you what it looks like. So if I type in this function, it would be x squared minus 5. We got that k is 5. So there's that. And then this is the tangent line to that graph. So 4x minus 9. And so if we look at both of those together, there's the parabola moved down 5, and then there's the tangent line. And so you can see that it's tangent to the parabola. It just comes by and like kisses the graph at that one point. So that is the bonus question. I'm going to open it up to you guys. You can type in the chat what other ones you want to go over. I'm not going to do the whole test, but I will, do a few. So you guys can type it, just type it to me privately if you want to, and I'll spend a little bit of time going over a few others. All right, so someone said 3 and someone said 6. I'm gonna do those in order, so we'll do 3 first. All right, so we've got e to the 7x minus y squared equals ln x. And it's just find the derivative. So if you get a gigantic mess, then you probably did it right. So we're going to do the derivative of each term separately. For this one, e to the 7x, that's itself. Exponential is itself. And then you have to chain on the derivative of 7x, which is 7. So 7e to the 7x minus, now this would be a power rule, so bring that down. This would be 2y dy dx equals, and then derivative of ln of x is 1 over x. And so that's all the calculus. From here on out, it's algebra. We want to get dy dx by itself. So I'm going to subtract this term over. So that'll be 1 over x minus 7e to the 7x. And then last step, we're going to divide by negative 2y. So it is all of this over negative 2y. And yes, you have a fraction in a fraction. That's okay. You can leave it like that. Here's what's not okay, and I did have some people do this, not an overwhelming amount, but I did have a few people do this. This x cannot come down to the denominator because you have to apply that to every single term. So you can't just slide that x down to the denominator. Now I did have some people do this, and this would be an equivalent answer. If you multiply all 3 terms by x, then you can do that. So if I multiply all 3 of these by x, then it would be okay. You can't just move that down for the 1 term. But if I multiply all of these by x, it would be 1 minus 7x e to the 7x over negative 2xy. And that's an equivalent answer. And I had some people do that, and that was totally fine. My only thing is that's more work, and do less work, guys. I think it bothered you that there was a fraction in a fraction. Just try not to let that bother you, because if you make a mistake simplifying it, then it's going to be wrong. And I want you to get all the points. All right, number 6. A cone is being filled up with water 4 feet cubed per minute. So the cubed is a big clue that we're talking about volume. So that is dv dt, and it's positive because it is filling up. And then we are told the radius equals 1/3 the height. And it says find the rate of change. This is our question mark value. Find the rate of change of the depth of the water. I'm going to use h for height just because it's called h in the formula, h for height. You can use d. I had some people do that, d for depth. It really doesn't matter, but that is what we were looking for. It's going to be positive because the cone is filling up. And then we're going to pause at the moment that the depth or height of the water is 2 feet. And I gave you the volume formula for a cone. And so the problem with this is we have an R and we have an H. And we don't have any information about R, so we have to substitute this out. So in place of R, I'm going to put 1/3 H. So I just took out the R and put in 1/3 H. And then we have the algebra steps to simplify this. So I'm going to square everything that's in those parentheses. That would be 1/9 H squared. And then lastly, I'm just going to multiply this together. So 1/3 times 1/9 would be 1/27 pi and then h cubed. So you had these, 3 steps of algebra you had to get through before you can take the derivative. But now I can do dv dt. And so power rule, this 3 is going to come down. You can leave it as 3/27. You don't have to simplify. I'm going to because most people did, and if you're following along with your work, I want it to look like what you put. 3/27 would reduce to 1/9, and then pi h squared dh dt, and then we're just going to plug everything in. So dv dt is 4, and h is 2. And you do not have to simplify any of this down. All you have to do is get dh dt by itself. So you're just going to divide all of this over. Now, I will show the simplification of it because, again, a lot of people did it. And if you're following along with yours, I want it to match. You can totally just leave it like this, though, and put units at the end. But just for the sake of finishing this up, because I know a lot of you did, 2 squared would be 4. So these 4s would cancel. And dividing by 1/9 would be the same as multiplying by 9. So this would be 9 over pi if you went the whole way through that. But again, I actually recommend against that. I would just leave the answer like this and put the units at the end, which are feet per minute. So the reason this was given as feet cubed is because that was for a volume. We just found a rate for the height, so it would just be feet per minute. All right, and I'm willing to do 2 more. I had someone type in the chat 3 and 7. If I do both of those, they will be the last 2. And then I just had someone type 4. So you guys are gonna have to decide because I'm not gonna do, oh, you know what, I already did 3. So I'll do 4 and I'll do 7. Those will be the other 2 that I do. All right, so number 4, let me write out the equation here. So this is find the instantaneous rate of change, so that just means derivative, at the point 3, 0. So you don't have to write the whole equation, you just need to find the slope, basically the slope part of the equation at 3, 0. So derivative of 3y, that would be 3 dy dx, minus 17 is a constant, so that is gone. And then here, derivative of cosine is negative sine, and then I need a dy dx there as well. Again, anytime you do a derivative with a y variable, you're going to chain on a dy dx. The only thing I did notice with this problem is a lot of people just wrote sine without the y there. Be careful, you can't have sine of nothing. There has to be a variable or a number there. So sine of y dy dx. Minus, and then this would be 4x. And so we're going to plug in 3 for x and 0 for y. So this doesn't have an x or a y in it, so that's just going to stay 3 dy dx equals, and then if you plug in 0 for y, sine of 0 is 0. So this entire part is just going to be 0. And I did that on purpose for you to make it, a little bit simpler. And then minus 4 times 3 is 12. And then last step would just be divide over the 3. So you would have negative 12 over 3, which would be negative 4. So negative 4 for that one. And again, the only thing I remember kind of being a problem there was just forgetting to write a y. So just be careful with that. Right, and then lastly, we'll do 7. So 7 is about the ladder sliding down the wall. So the ladder is a constant 20 feet. That is not changing. It's not a growing or shrinking ladder. So that's going to stay 20 feet. It's sliding down, and so the bottom of it is sliding out. And so I need variables for those two lengths. All right, so they tell us, let me see, the ladder is sliding down the wall so that the top is moving at a rate of 0.25 feet per second. So this is moving down 0.25 feet per second. So that's our dy dt, and it will be negative. And a bunch of people missed that negative. Just be careful with that. The reason it's negative is the ladder's sliding down, and so that distance is decreasing. So that would be a negative rate. And the question is, how fast is the foot of the ladder moving away from the wall? So dx dt is our question mark. That should be positive because the base of the ladder is moving out. That distance is lengthening. And then we're going to pause at the moment when the foot of the ladder is 9 feet from the wall. So when x is 9 feet. So the relationship between the variables is going to be Pythagorean Theorem. X squared plus y squared equals 20 squared, which would be 400. And so this derivative is 2x dx dt plus 2y dy dt equals 0. And that went well. Pretty much everybody remembered that that derivative of a constant was going to be 0. So that was good. And then I'm going to cancel out the 2's. 0 divided by 2 would still be 0. So it's just simpler to get rid of those. And then we're ready to plug in. So x is 9. And dx dt is what we're looking for. And I don't have y, so we'll have to come back to that. And then dy dt is negative 0.25 equals 0. So if you're missing something, you're going to go back to the original relationship and plug in what you have. So I'm going to plug in 9 for x. So 9 squared is 81 plus y squared equals 400. And I'm going to subtract the 81 over, so that's going to be 319, which is not a perfect square. So we're just going to leave it like that. Even if it was a perfect square, you could just leave it as square root of whatever. You know, you don't have to simplify that down. You can just leave it alone. All right, and then we need to get dx dt by itself. So this term is negative because of the negative in there with the 0.25. So when I move it over, I'm going to add it to the other side. So we're going to get 9 dx dt equals root 319 times positive 0.25. Again, if this term is negative, like if you want to think of it this way, let me erase the negative and put it out front. That whole term is negative, so we add it to the other side. So it'll be positive when it moves over there. And then we're going to divide by 9. And that makes this answer turn out positive like we needed it to. And again, that's because the base of the ladder is moving away from the wall, so that distance is growing. And then units are feet per second.